Okay, so now let's go ahead and try part C. So part C gives you this shaded diagram right here. And what you have to do is you have to first describe the shaded region in words, and then also describe the shaded region in symbols. So let's start with in words. So here I've defined what L is. L is the event that the business stays in business for the next 5 years. And M is the event that the business is in a shopping mall. So both of the, according to the shaded region, we're not looking for either of those, right? It's not L, it's not M, it's the outside portion of that. So what we're looking for is how do we say that in words? Well, if we're trying to say not L and also at the same time not M, well, what we're saying is that the business is not going to stay in business for the next 5 years, nor is the business located inside a shopping mall. That's what this is saying. So how do we describe that in words? Well, if we're looking for, in symbols, the way we describe that in symbols is, well, we know that it's the union, but the complement of the union, right? Because the union is precisely what we're not looking for. So if we draw the L, union, M, complement, that's exactly what we're looking for, right? This portion right here is inside the complement. This is the portion that we're not looking for. So we do the complement that and we get the outside region. So moving on to part D. So part D asks is L and M independent. So if you recall your rules for independence, the major rule for independence is this. If you have two events, so L and M for us, in order to determine whether or not they're independent, you need to do the probability of L given M, so one event given the other, must equal the probability of the first event. So whatever you put in the first event, it must equal that. So this whole probability right here must equal this event right here if they're independent. Now remember, you can see independence on the exam in different ways. For example, if we break this up using our conditional probability rules, you can also see it written like this. L intersect M all over the probability of M is equal to the probability of L. So this whole line is saying the same thing as this line, but it's just a different way of looking at it, right? It's a different look. So this is the second way that you can see independence being shown on the exam. But there's also a third way that you can see it. So if you do some algebra and you multiply the probability of M to both sides, right? The probability of M will cancel here and it'll go here. So another way that you can see independence is L intersect M is equal to the probability of L times the probability of M. So this is the third way that independence is shown. So these are the three, and only these three ways are the way that you can see independence. And if any of them are true, the other two must be true. And if any of them are true, that also means that they have to be independent. If they're not true, then they're not independent. So let's go ahead and just take one. Let's go ahead and try using this one. This one looks like the easiest one. We already know what the intersection is, 0.1, so I'm just going to go ahead and write this over here. So 0.1 is this intersection right here. And then we know that the probability of M is 40%, right? So we can put the 0.4 here. So this is equal to 0.25. So what this is saying is that if they're independent, this number here needs to equal what the probability of L is. Well, we know that the probability of L is 20%, which is clearly not 25%. So in this case, they're not independent. So let's go ahead and try the mutually exclusive one. Mutually exclusive, so what does that mean, mutually exclusive? Mutually exclusive means that the events A and the events B, whatever they may be, those two events have no intersection. Well, in this case, you can see that the event L and the event M clearly have an intersection. So mutually exclusive means that the two events don't have an intersection, but here we see an intersection, therefore they can't be mutually exclusive. So let's go back to independence. What does independence mean? Well, independence means that the first event does not have any effect on the outcome of the second event. For example, if you have two coin flips, right? If you flip the coin on your first try, whatever it may be, heads or tails, that result has no effect on the second coin flip. You're going to flip that coin flip, and it didn't matter what the first one what happened in the first one. So those two events would be independent. But clearly, in this case, there is some relationship between whether or not you stay in business for 5 years and if you're in a shopping mall. So So therefore, these two events are not independent. So let's take a look at the part E. What is the real-world interpretation of the statement, the probability of L is 20%? So this is 20%. They're asking, well, how do you say that in words, basically? What is the real-world interpretation? Well, if this is what L represents, the event that the business stays in business for the next 5 years, then what that is saying is that you have a 20% chance for your business to stay in business for the next 5 years. That's what that says in real-world terms. So part F, explain in real-world terms what the difference between probability of L and the probability of L given M tells you about the small business. So probability of L we've defined, right? We knew that it's the business that stays, the probability of the business stays in business for the next 5 years. And then here we have L given M right here. So what is the interpretation of L given M? So if you're given something like M here, that means you know for sure it's true. So you know for sure that your business is in the shopping mall. So what is the probability that you'll stay in business for the next 5 years? That's what this is asking right here. So if you're staying in a shopping mall and you realize that the probability that you stay in business for the next 5 years is 25%, right? That means that your percentage of success has kind of increased a little bit. Before it was 20%, given no information, just the probability of L. But once you're given that you're in the shopping mall, that means it must have had some sort of effect on the probability of L. It means that your success rate for staying in business must have gone up because your probability went to 0.25. So the final answer is, if you are in a shopping mall, the probability that you stay in business for the next 5 years is 25%. That is the kind of difference between L and M, and that's how you can interpret